So thank you for this opportunity to talk to you guys. When I got to Goddard 10 years ago, can't believe it's been that long, we had a system on the floor at the time. It was number 18 in the world. It took up a space that was as big as this area in here, 100 racks, 120, 125 kilowatts of power, 3 teraflops. 3 teraflops. I can hold 3 of these in my hand, and that's what we have 10 years later. So think now, 10 years from now, when we'll be standing on the next Starship Enterprise, what will we be holding in our hands 10 years from now? It's really exciting. So I want to thank you guys for this opportunity. I am Dan Duffy. I am the lead systems engineer for the NASA Center for Climate Simulation. We are one of the 2 high-performance computing centers within NASA. We're located at Goddard Space Flight Center just outside of D.C. So we are funded by the Science Mission Director within NASA, and we are there to provide a high-end computing environment specifically designed for climate and weather. The current operational forecasts that are being done right now run on hundreds of cores, possibly even a few thousand cores if you're doing ensemble calculations. The science is trying to get to a point where they're doing global climate models at cloud resolving levels. This is 1 kilometer resolutions and finer. This, if you take a look at the equivalent number of today's cores, the equivalent number of today's Xeon cores, to get to that resolution with the physics and all the dynamics in there, you would require about 10 million cores to do that calculation. 10 million cores. It's about 20 megawatts of power. That's about a small city, about 20,000 houses. There's no way we have that budget to even build, purchase, acquire, and install and run that system. So the adoption of accelerators are important for us. They have we need the accelerators and the technology that they bring us in order to meet the science goals. So this slide tells you the details behind the current installation. It's been about a month or so of installation effort with 480 IBM iDataPlex nodes. There are also 1 Intel Phi per node right now. Each node can actually handle 2 Intel Phis. We installed the Intel Phis into 2 chunks. The first 240 Intel Phis came in on a Friday night. IBM was there, the team was there from NASA Goddard, both civil servants and contractors. They stayed through the night. They ended up getting 240 of them installed by about 2 o'clock in the morning. And they sent me some emails, gave me some calls, and I was up and running on them the next day. That was a Saturday. So we ran on that for a while, and then we got the second 240 Intel Phis coming in. Well, they were due to be delivered on the day that the Hurricane Sandy was coming through. The Monday that Hurricane Sandy was hitting everything. So we redirected the delivery all the way out to, I think, Kentucky, put them on a truck, drove them all the way over to us. They arrived the Wednesday after Hurricane Sandy came through. We still had people out, houses without power. We were battling hurricanes, we were battling power outages. We got these systems installed very quickly. Another 2-3 hours installation on that day, and I was up and running by that night. These are pretty impressive systems that you can get these things as quickly as we can, install them in these nodes that we're talking about, and we achieved 52nd on the top 500 list. It's a modest number. Jay's got a lot bigger number back here that you'll hear about in a second. But if you take a look at this peak capacity of this system, 620,000 gigaflops. To give you an idea what that is, we all deal in this business, but to still have a sort of an understanding of what that means. If you took every person on the face of this planet, all 7 billion people, and you had to multiply 2 numbers together every second for 24 hours, that's what this system can do in 1 second. And when you think about it like that, it's pretty amazing. And I'm very excited to get our climate scientists on this. We have a couple of very important meetings. We wanted to make this announcement in 2012, SC12, but we have a couple of important science meetings that we want to get the science guys on there and try to run these very high fidelity global climate resolutions. So thank you again for the opportunity to talk, and I appreciate it.